Dear participants of the conference, your attention is presented experimental studies of the dynamic parameters of air distributors during the interaction of counterjets. The authors of the study are Zaitsev Oleg, Semicheva Natalia, Alexey Burtsev Research Scientist Department of Infrastructure Energy Systems, Southwest State University, Mennanov Eldar Research Scientist Crimean Federal University named after V.I. Vernadsky, Zaitseva Katerina Research Scientist Belgorod State Technical University named after V.G. Shukov. In the last decade, new energy-efficient building life support technologies based on the use of periodic operating engineering systems have become increasingly widespread in the world. This is especially true for ventilation systems that are also operated periodically, and in public and industrial buildings this mode is regulated by the inclusion of the systems themselves. But very often the quality of the system depends on the technological parameters of the air in the room, in particular, the attenuation rate of supplied jets and methods for controlling the created velocity field in the volume of the room. The most promising direction is the use of interacting oncoming, but not coaxial supplied jets in non-stationary modes. However, various noises arise at the same time, that is, it is necessary to investigate the acoustic characteristics of the resulting flow. Due to the fact that in order to increase the intensity of attenuation of the velocity of the resulting air flow, it is necessary to reduce the distance between the axes of the nozzles. Another series of studies was carried out, where the interaction of longitudinal flat slits was used instead of round nozzles. Experimental studies were carried out on the installation, the scheme of which is shown in Fig. 1 under the following conditions and simplifications. Supply nozzles, slots with a speed extinction coefficient m equals 2.5. Their width did not change and was BO equals 20 mm. The linear size of the ducts did not change and was h equals 1.5 m. The air ducts are made in the form of uniform flow air ducts. The distance between the axes of the nozzles was variable and was, low 1 equals 40 mm equals 2 BO, low 2 equals 60 mm equals 3 BO, low 3 equals 80 mm equals 4 BO. Measurements of the air velocity V were carried out with a Testo 405 V1 thermoelectric anemometer using a coordinate system with a grid of points 5 by 5 cm in sections I, 2 to 2, 3 to 3, 4 4, VV. Air was pumped using a fan 1 DC electric motor through the air ducts 3. AB is equal to 350 by 350 mm, and through the supply flat slots BO equals 20 mm was pumped into the structural part of the air distributor. The study of the interaction of non-isothermal jets was carried out in a separate experimental session. The interaction of oncoming misaligned jets with a temperature above 8 degrees Celsius from the temperature of the medium into which the resulting air flow entered was studied. Under the conditions of the experiment, the temperature of the medium into which the resulting air flow entered is plus 15 degrees Celsius and the initial temperature of the studied jets is plus 23 degrees Celsius. Based on the results of the performed experimental studies, a nomogram of the dependence of the sound power level L on the velocity of the air jet outflow from the nozzle V and the dimensionless area S is constructed, as the ratio of the free section of the nozzle S to S0 equals 0.1 square meter. That is, equals S/S0. These graphical dependencies are approximated and the corresponding analytical expression is obtained. Based on the results obtained, the following conclusions were drawn. 1. According to the experimental data obtained, the optimal line ratios for obtaining a sufficiently uniform exit velocity of the resulting airflow from the air distributor with the interaction of countermisaligned circular jets are the following. X/XP equals 0.5. H/H equals 0.45, low/do equals min, at low equals 100 mm. At the same time, the effectiveness of the use of countermisaligned circular jets will be maximum. If L0/D0 equals 0, then this means replacing the cylindrical nozzles in the air ducts with flat longitudinal slits and switching to the use of countermisaligned flat jets. 2. The geometric and flow characteristics of air distributors have been determined and optimized for different cases of interaction of oncoming misaligned jets. It is established that the attenuation of the parameters of the resulting flow occurs faster in the case of using air distributors with the interaction of opposite misaligned slits. The reliability of data research is ensured by the use of experimental planning methods, methods of statistical processing of research results, and the use of effective mathematical methods in the development of research methods. Thanks for your attention.